Today, we're pulling back the curtain on the internet's invisible powerhouses, the secret ingredients that keep your favorite websites running smoothly and your data safe. Let's dive in. Have you ever really thought about it? How does a massive site, say YouTube or Amazon, manage to load instantly for millions of people all at the same time? It's not magic, believe me. It's a really clever system of things called proxies and load balancers. And to make sense of it all, we're going to use a simple analogy. So for a minute, forget about servers and networks and all that tech stuff. Just picture a super busy, super popular restaurant. Let's start with your side of the story. Imagine you want to make a reservation, but you don't want to call the restaurant directly. So you hire a personal assistant to handle it for you. In our story, this assistant, that's your forward proxy. A forward proxy is exactly like that assistant. It's a server that sits between you, or more likely your entire company's network, and the huge public internet. When you want to visit a website, your request doesn't go there directly. Nope, it goes to the forward proxy first, and then the proxy makes the request for you. The website you're visiting never even talks to your computer. It only ever talks to your assistant. But this assistant does a lot more than just make calls. It's also your security guard. It can filter out malicious code before it ever even gets to your network. For a company, it can blacklist certain websites to keep employees focused and safe. And get this, if a bunch of people in your office want to watch the same viral video, the proxy saves a local copy. We call that caching. So it only has to be downloaded once, saving a ton of bandwidth. Okay, so your reservation is made. Now, let's flip the script. We're now looking at this whole thing from the restaurant's point of view. You've arrived, and this is where we meet our second key player, the server's very own gatekeeper. Think about it. In a packed restaurant, you don't just walk in and grab any old table. That would be chaos, right? You go to the host or the receptionist at the front desk. They know which tables are free, which servers are available, and where to seat you. Well, that receptionist is our reverse proxy. So here's the crucial difference. A forward proxy works for you, the user, but a reverse proxy works for the server, or in our analogy, the restaurant. It sits out front, in front of all the actual web servers, and intercepts every single incoming request from the entire internet. It's the single point of contact, the public face of the whole operation. And this receptionist is a multitasking genius. It's a shield hiding the hundreds of internal servers from direct attack. It handles all the security, like SSL encryption, making sure your data is safe. And, just like the forward proxy, it can cache popular content to deliver it faster. And, most importantly, it performs load balancing. It's the one that decides which table, or which server, is best ready to handle your request right now. Now, this is where things can get a little fuzzy for people. We just said a reverse proxy does load balancing. So, is a reverse proxy just a fancy name for a load balancer? Well, not quite. Let's clear this up. This is the key takeaway, right here. A reverse proxy is basically a Swiss Army knife for servers. Load balancing is one of its most important tools for sure, but it is not the only tool. Remember all those other jobs? Security, caching, encryption? A reverse proxy does all of that in addition to directing traffic. Okay, so you might be thinking, hang on a minute, I use AWS or Google Cloud, and they have a service called a load balancer. Is that a reverse proxy? This is an excellent question, and it really gets to the heart of how modern web architecture is built today. And the answer is, in a real professional environment, you don't choose one or the other. You actually use both. You layer them to create an incredibly tough and secure system. It's not about which one is better, it's about teamwork. So let's break down how these two traffic cops work together. You'll see how they form two separate layers, each with its own special job in managing the flow of requests. The cloud load balancer, that's your first line of defense. Its job is pretty simple. Take all the traffic coming in and spread it out, often just by sending requests to whatever server is the least busy. But the reverse proxy, like the super popular Nginx, sits behind it. It gets the traffic from the load balancer and then performs much smarter, more intelligent routing inside the private network. To bring our analogy back, the cloud load balancer is like a tragic director outside the restaurant, just making sure cars can get into the parking lot. But the reverse proxy is the smart receptionist inside. This receptionist can look at the incoming request, the guest, and make intelligent decisions. It can route all requests from the same user to the same server to keep their session active, or route requests for the blog to the blog servers and requests for the API to the API servers. It's much, much smarter. So let's put this all together. What does a typical high-performance web application actually look like out in the wild? A really common pattern is to use a high-performance reverse proxy, like NGX, in front of an application framework like Node.js with Express.
See, NGX is incredibly fast and efficient at handling things like serving up static files, images, CSS, and managing thousands of connections. It offloads all that heavy lifting, which frees up the Node.js application to do what it does best: process dynamic requests and run the core business logic.
So let's trace the whole journey. You click a link. Your request first smacks into a big cloud load balancer. That load balancer does a simple check and forwards the request into the private network, where it then hits the NGX reverse proxy. NGX inspects the request and makes a smart decision, routing it to the right Node.js server. That server processes it, and the response travels all the way back along that same path. And what is this whole setup protecting? Well, it's protecting the hundreds, sometimes thousands, of internal servers that hold the actual application code and all that sensitive user data. By having these layers of proxies, none of those critical servers are ever directly exposed to the dangers of the public internet. So the next time you seamlessly load a website, you'll know about the complex dance of assistants and receptionists, of forward proxies, reverse proxies, and load balancers, all working in perfect harmony behind the scenes. It kind of makes you wonder, what other invisible architecture is out there making our digital world possible?